Okay, students, so in this clip, we're going to be going over an example on how to solve quadratic equations by factoring. This is part two of the two-part installment. Um, so let's go ahead and write down the instructions for the question. Solve a given quadratic equation, the given quadratic equation by factoring. Then prove the answer is correct. Prove that your answer is correct by doing a check. Okay. All right. Okay. Now let's write down the equation that we're going to be doing for this example. A quadratic equation is 2x squared minus 5x equals 12. All right. So when you take a look at this equation, it has to be in standard form first before you advance proceed to factor. So is this in standard form? The answer is no. Why? Because standard form requires for the equation to be equal to 0, and the variables must be in descending order. Okay, so first of all, let's make it equal to 0 to accomplish that. I'll subtract 12 from both sides. That gives me 2x squared minus 5x minus 12 equals 0. Now, is this in descending order? Absolutely. This is degree 2, degree 1, and degree 0. All right, now before I proceed to even try to determine how to factor this, let me see if there's any common factor in all three terms that I can extract. So to accomplish that, I'll break everything down. Decompose it, 2 times x times x minus 5 times x. And then 12 brings that into 2 times 2 times 3. Is there anything that is common in all three terms? No. So we're going to reassemble it back as it was. So we have 2x squared minus 5x minus 12 equals 0. All right, now this clearly is not a perfect square trinomial, neither is not that it's a perfect square. So we're going to advance to use the X game or the AC methods to factor this out, okay? So we'll make our X. Um, AC goes on the top and B goes on the bottom. All right, so I have AC on the top and then B on the bottom. Note this is A, B, C, okay? So AC is negative 24 and B is negative 5. So what two numbers multiply to give you the top and add to give you the bottom? Let's make a factor tree. Listen all the factors of um, 24 and see which pair can be combined to yield the bottom number, okay? So 24. I know one goes into 24, and every other number, one goes into 24 24 times. Two goes into 24 12 times. Three goes into 24 8 times. Four goes into 24 6 times. Five doesn't go. Six is already here, so we have a complete list. So which combination gives me 5? This gives me 10 or 2? No, this gives me 11 or 5. So this is a pair that works because when I subtract, I'll get 5. And that's my target number. All right, so I'm going to put it here, 3 and 8, and then resolve the sign. Since the number gets smaller and the difference is negative, we have to make the bigger number negative, like that. Okay, so that works. So we're going to insert these two numbers to make it a 4-term quadratic that can be factored by group. So we have 2x squared, and then we're going to insert plus 3x minus 8x minus 12 equals 0. Okay, so we're going to break it down the center and factor by grouping. So to do this, we're going to break down every single term and then extract common factors, okay? So for the first one, we have 2 times x plus 3 times x, and then minus 8 can be broken down into 2 times 2 times 2 times x, minus, and then 12 can be broken down into 2 times 2 times 3 equals 0. If you can't do this decomposition manually, mentally, you can always use a factor tree. 2 goes here 4 times, 2 goes here 2. So you see 8 is 2 times 2 times 2. And 12, 2 goes here 6 times, 2 goes here 3 times. 2 times 2 times 3 is 6. All right, so from the first two, we can extract x, subtract x. So we have x on the outside times 2x plus 3. And then if you look here, we can take out two 2's. Take out a 2 and a 2, take out a 2 and a 2. So we were left with, also bring out a minus. So 200 times 2 is 4. And then x, since you took out a minus, this has to change to the opposite, which is plus. Actually, I have a 2x left there. I have a, these two 2's came out, so I'm left with a 2 and an x. 2x and then plus 3 equals 0. Now let's check. Is my answer correct? Yes, because these two quantities are the same. So what I'm going to do is factor them out. To factor out these two quantities as 2x plus 3. And then I'll be left with what's on the outside, which is x minus 4. So we have times x minus 4 equals 0. Okay? So let me write this factored form. So x plus 3 times x minus 4 equals 0. Now we're going to use the zero product property to finish this off. So we'll have set each factor to 0. 2x plus 3 equals 0. And x minus 4 equals 0. All right, so let's go ahead and solve it. From the first one is a two-step procedure. We'll subtract 2 and divide by 2. We'll subtract 3 from both sides. We have 2x equals negative 3. And then divide by 2. And your answer is going to be x equals negative 3 over 2. All right, and this term you're going to simply add 4 is a one-step equation to solve. The answer is going to be x equals 4. All right. So your solutions, are x equals negative 3 over 2 and 4. Okay. Now we're going to do a check to see if our answers are correct. All right. So check. The original problem when I write it is 2x squared minus 5x equals 12. So that's what we're going to be checking. Okay. So we're going to test the first answer. Let's test x equals negative 3 over 2. So to do this, we're going to plug in this answer into the x's, into this x, and into that x. Okay. So let's go ahead. Let's go ahead and do that. If we do that, we're going to have 2 times negative 3 over 2 squared minus 5 times negative 3 over 2. Is it equal to 12? Is it? All right. So we proceed. We're going to square this first using the order of operations. Exponent goes before you multiply. So you can have 2 times, if I exponentiate a negative, if I square negative, it becomes positive. If I square 3, it becomes 9. If I square 2, it becomes 4. So anytime you square, you have to square the numerator and the denominator. Okay, the power affects both, owing the properties of exponents. Okay, all right, so we have 9 over 4 minus, this minus times that minus changes it to plus. So they have 5 over 1 times 3 over 2. Is it equal to 12? Now in this, on the left side here, we can reduce. 2 goes into itself once, and 2 goes into 4 twice. And now multiply it across, we're going to have 9 times 1, which is 9. 9 over 2 plus 5 times 3 is 15 over 2. The question is it equal to 12? Is it? If we combine further, 9 plus 15 is 24. Is 24 over 2 equal to 12? Is it? 24 over 2 is 12. Is 12 equal to 12? Absolutely. So our answer, first answer is correct. All right. Now let's advance to check the second zero that we got, or second root or solution. In the second root, we're going to test. X equals. What is the second answer? 4. We're going to test x equals 4. So the question is 2 times 4 squared minus 5 times 4. Is it equal to 12? Is it? If you square 4, you get 16. Is 2 times 16 minus 5 times 4 is 20. Is it equal to 12? Is it? 2 times 16 is 32. Is 32 minus 20 equal to 12? 32 minus 20 is 12, right? Is 12 equal to 12? Absolutely. So our answer checks out. So since our two answers are generated a true statement upon substitution, that means the initial answer we got is correct. So we can box it with confidence and be happy. Okay? So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here. More videos you can also share with your friends via Facebook or Twitter. More videos can be found on my blogserve.com. Thanks again and have a wonderful day.